A new mailbag arrived. I was not able to show you all the goodies in the last mailbag video. Let's continue the frenzy. Grüezi YouTubers, here is the guy with the Swiss accent, with a new episode and fresh ideas around sensors and microcontrollers. Next one is in cardboard. 4 different modules. These are ESP32 modules, and obviously they have to do with RF because they have an SMA connector here. It's from eByte and we have to check what it is. These are 433 or 868 modules. You get 2 different versions, and they use an SX1276 or a 1278, which is a LoRa chip. And if we go to the description, we see they have already built in the whole protocol, so you can just use them as transparent modules. You do not need to program too much. You just connect them to one of your serial connections. So they have different modes, for example, point-to-point, or also broadcast from one sensor, from one point to several points. So it might be an interesting thing to test them once, if it is easier than use a Hope RF module or so, because you do not need to do a lot of programming with these. It's probably easier for a beginner to use one of those than to use a normal LoRa chip, but they are not LoRaWAN compatible, just to make it sure. They are just for point-to-point. 2 of them are for 433 and 2 of them are for 868 MHz. Next one looks also like Banggood. This one is the interesting thing. A chip with a lot of pins and all broken out to pin headers and a USB connections. And it is a Cypress FPGA. Now, FPGA are complicated things, but this one is very special. You can use this with Sigrok, and you can build your own logic analyzer with just by connecting it to your computer and start Sigrok. I bought this also at Banggood for $7, and it is something like that. It is a logic analyzer, but this has only 8 channels, and this one should have 16 channels, and it should work with the open source software PulseView from Sigrok. This is Sigrok PulseView, and here we can select our device, which is a Cypress FX2, and now we see here all the 16 channels. I connected my frequency generator on D8 and it creates a 1 kHz signal. I have 1 megasamples, 1 megahertz, which means it will sample for 1 second if I press run. And now we can move in and we can add the different decoders. The simplest one is just timing, and we have to assign the pin, which is D8. And now we see the timing, 500 microseconds up and 501 microseconds down, 499. This comes from the sample rate of 1 megahertz, so it's not completely precise, but we see here clearly the rectangle. I changed now my frequency generator to a pulse, and really we have now a pulse. The pulse is 200 microseconds and 800 microseconds is here, and the average obviously is still 500 and 500, which is pretty useless in this situation here. So PulseView is an open source software which can be used with this FPGA. And we do not need any protected software to do our logic analysis. The next one is already opened because I had to check to confirm the package before the mailbag. It's not quite clear for most of you probably what it is. I have a second one. Maybe you see it easier like that. A second one which is similar. And these are better PIR sensors. This is a data sheet. You see you get 3 of them. I have 2. I have a long distance and I have a standard detection one. And the standard should go up to 5 meters and the long distance up to 12 meters. And they also should have more than one zone where they detect movements. And I hope I can create a video where I compare these sensors with a normal cheap PIR sensors. I got this tip from viewers. And here you see why this is important. A normal PIR sensor is around $1 or less, and these cost $10. So they have to be quite better for their higher price. But we will check that in a future video. Next one. These are only battery connectors, but quite special ones because they do not fit for an AA battery or an AAA battery or for a LiPo battery. These are for a special format. These are for the CR123A batteries. They fit perfectly here. By the way, I bought also rechargeable batteries, these live fire batteries, but actually I tested them. They are horrible. They have about 1/10 of the capacity which was written here, which is quite obvious. They cannot have 2200 milliampere hour because they should be much bigger for this capacity. So it's a fake, but they at least would have the same format here. And these batteries are lithium batteries and they are quite good in cold weather situations. I did not have any battery holders for them, so I have them now. Next one. They also have some kind of battery on it. It's 5.5 volt. Let's check what it is. I think I know what it is. You see here the number. It's 2557. And this is because it has a chip on it, the BQ25570. And this is a ultra low power harvester for charging batteries or powering our IoT devices. And I plan to do a video about power harvesting with solar cells and stuff like that. And I bought a few of these boards. This is one of them. Now they are not at all cheap. They cost $10. One of these boards, or even $12 if the shipping, or $13 if the shipping is included. But maybe it's worthwhile if they really work well. We will check if it's worth the money. Next one. These are IR diodes and they are 940 millimeters, 120 degrees opening and 3 watts. These are the same, but they have an opening of 60 degrees. And this device here will be used to measure if these diodes are really on 940 nanometers, because viewers told me that the diodes I used for the remote controller for the TV, mine was I think at 860 or 870 nanometers, and they told me that the receivers for IR are on 940 millimeters, and I checked it and they were right. And this makes a big difference, and I will do a whole video about measuring these IR diodes. I have now an instrument, a simple instrument where we can check it, and I have also some IR cameras where we probably can see the IR pattern, whether they are 120 degrees and 60 degrees or not. So stay tuned if you are interested in infrared. This one is also already opened. No, it does not come from JLCB PCB, as you will see. Dear Andreas, it is a package from a viewer. And he gave me all the description which are necessary to understand. And you see, it is also has to do with power. And we had a discussion on YouTube about how to do this universal power supply, if you remember. And Gopi had his own opinion, and then he said he will send me stuff to try out. So I got 3 different boards. This is obviously one he bought, just a normal boost converter. And this one he made on his own. And it contains this small chip here. So thank you very much, Gopi, for your work and your contribution to the channel. I'm sure I will be able to use this during one of my videos where I do power stuff for IoT devices. Next one is already open. Many of you might recognize this module is an ESP. Very well packaged in 2 bags. Through-hole components, very strange these days. This is an ESP32 module, and this is a very special breakout board. It's like that. It will be soldered like that, and this is very breadboard friendly. You do not lose any pins if you mount it like that. It just covers 1 pin, and this is the minimum to connect it to the breadboard. And I thought this is quite an innovative solution, and I wanted to show it to you. And we have all necessary things like the 2 switches, 2 resistors, and a capacitor. And it should be possible to solder all this in a few minutes. Next one, fluffy package here, and even more fluffy material inside. It's also a module, a small one. It's a 25504, and it looks like it has to do with power because of these connectors here. This is also a ultra low power boost converter with battery management, but what I see here, it's no more recommended for new designs. But you see here the speed of our industry is ridiculous. The BQ25504 device is the first of a new family of intelligent integrated energy harvesting, and it's already no more recommended for new designs, even if it's the first one. So, but it has also MPPT tracking and stuff like that. So it's definitely something which will go into this solar stuff. Next one is for sure not from China. It is from Germany. And it is from a viewer. It is from Tobias. And it is a Microwakeup. Have fun, yeah, exactly. Let's have a look what's in this Microwakeup. He sells it on Tindi, and what is special, the Microwakeup is a plug-and-play solution. If you want to add a button, switch your PIR sensor to your project. The board supports 2 modes for normally open and normally closed switches. And it does also the debouncing. It has a very low power consumption, and you get sample codes here. So if you want to build a small and power efficient device, this might be a good solution for you. Thank you, Tobias, for sending me this Microwakeup. Next one. This is a RF power meter. Let's connect it to power. Frequency 800 megahertz, I assume. No, it's 500 megahertz. And we have no signal, minus 60 dBm. So let's quickly check the data sheet, or what we got from AliExpress. First, it costed $26.50. The frequency range is probably from 1 megahertz to 5 gigahertz. So it's definitely good for LoRa, which is 868 megahertz. And the measured power is 1 nanowatt to 2 watt. But it also says here from minus 45 to minus 5 dBm, and minus 5 dBm is for sure not 2 watts, because 1 watt is already 30 dBm. So something is wrong, and cautious as I am, I assume that this is the maximum. To check this power meter out, I use this LoRa board, which we used before also for some tests, and because it has about 15 to 17 dBm, I have to reduce the power with a 20 and a 10 dB attenuator, so we are below the minus 5 dBm, which we found in the specification. Now first I check with a spectrum analyzer. If we put max hold, then we have 18 dBm maximum. Now we compare it with the power meter, with my new power meter. I adjusted also the 30 dB from the attenuators, and we get now 18.6 dBm, which is very close to the 18 dBm we got on the spectrum analyzer. So this small device here is pretty okay, I think. I also checked it with my 2-watt Baofeng ham radio on 145 megahertz, and it was also okay. And it even has a serial output. This is PADI, and I can log this information. The main component of this power meter is this AD8318, and it goes from 1 megahertz to 8 megahertz. And here we see also that the linear range stops at minus 5 dB. So this is the right specifications from roughly minus 50 to minus 5 dB. We have a relative flat behavior. So for sure this small device is worth the money if you want to know the output power of one of your RF devices. Next one. Many of you might know what this is. It is a tester for Ethernet cables. One here and one here. To test this device, I brought a short Ethernet cable, and you plug it in here, RJ45, and here. And now we go to network function and press test. And now we see each wire is tested, and these wires are okay. You would see if one wire would not be connected or 2 wires would be short-circuited. You would see it here or here. That is the normal test procedure of most of these testers. But this one has another functionality, and this is why I bought this one. I switch it to scan, and I press the scan button here, and I hear something. Maybe I put the microphone a little bit closer. And if we approach the cable, it shows us that this is the cable which the transmitter is connected to. Now you also have a light, and in the dark server rooms or whatever, you can easily detect with this function which cable is which. Of course, you should have it done like that. Here is a laptop cable, but if you forgot to do this or if you changed something, it's quite handy to have such a function here. Definitely the network and the scan function is quite handy and it works. It also has a mechanical switch, so I assume that the battery is switched completely off and I do not drain the battery if I don't use it, because this can well stay in the box for a year or more. So this one definitely is a buy. That was all for today. As usual, you find all the links in the description. I hope this video was useful or at least interesting for you. If true, please consider supporting the channel to secure its future existence. You find the links in the description. Thank you. Bye.